let's take a look at K nearest neighbors. This is one of the nicest machine learning algorithms in the sense that it's cool to visualize and most people can make sense of it. So what is it? Okay. Well, KNN, which is short for K nearest neighbors, it's a unique machine learning algorithm. Note that K here is a positive integer. So what's the main idea? You basically plot your data. Now, you could imagine it if it was two-dimensional or three-dimensional, but in reality, it's going to be higher dimensional. And so you can still visualize it though, and you give everything a label, right? Like all your data is labeled, which is your Y value. It's what you're trying to predict, okay? So like if everything was predicting a color, you could imagine that you have all these points and these points are in fact different colors. Now, given a new point with an unknown label, K nearest neighbors gives it the same label as its nearest neighbors. Simple, beautiful idea. So if K equals 3, the new point will match the label of its 3 nearest neighbors. It's that simple. So if you're in a neighborhood where 2 points are blue and 1 is red, you take on the value of blue. You know, if the labels are 0s and 1s and 3 of the neighbors all have 1, then of course it's going to have a value of 1 as well. If K equals 5, similarly, the new point will match its 5 nearest neighbors. So here's a nice visual of the data. The idea is, whoa, what's the green, circle? Like you have to choose whether this is going to be red or blue here. And so, like, how does it find its 3 nearest neighbors? Well, you go out, it's using Euclidean distance here in terms of its radius until you encapsulate 3. And note that since in this case, the first circle, 2 of them are red, it would take on a red value. So for KNN where K is 3, you get a red triangle. But if you go with 5, you're in the larger circle. Now the majority is blue and it would take on a blue value. So it does depend on sort of your K, right? It's going to make a difference often what the actual value you're going to pick for your new and unknown point, okay? Here's another visualization. And so you can end up with neighborhoods. So this is when K is just 1. Excuse me. It takes the map of its nearest neighbor. And it's kind of cool because it's a color-coded map. And so you can imagine if you have a new dot and you drop it in any of these areas, then it'll be red, blue, or green, okay? Nice to color code like for the visualization, but it doesn't have to be like your Y values colors. They could be like, have 0, 1, or 2 as the labels, for instance. Okay, here's a map of 5 nearest neighbors. So this is interesting because you have some clear, you sort of have more general regions, but then I think you have what are some unknown regions, which is why it's not one of the actual colors. I'm not honestly sure how to interpret the visualization there in terms of the output. You could always reduce it to a smaller one, I suppose a smaller K, if you don't have a clear value. I would also say it's common in KNN with classification to use 1, 3, or 5, because then you're definitely going to have a majority and you're going to force it to pick something. Because it's 50-50 if it's 2 and 2, what do? Okay. I'm going to come back to this one because this is a GIF and it's a visual, and I got to go more full screen to show it to you, but it's really cool. And so basically it's saying, hey, well, what's this new point? It looks like maybe if you're just 1, it would be blue, but if you're more than 1, it would be red. And it's going to show you how to draw those color maps that we just saw. Okay. So we'll come back to this one. And so the examples here given we're classifying into different groups. So can you use it for regression? Well, you can, okay? Instead of matching labels, you take the mean value of the neighbors. Like that's the whole idea. So if K is 3, you take the mean value of the 3 nearest neighbors. If K is 5, you take the mean value of the 5 nearest neighbors. Housing data, this would be cool to try, right? Now here, neighbors, by the way, in KNN it's all of the data input. Doesn't mean physical location, but it's kind of cool because within a housing, you could conceivably base it also on the physical location, okay? So what are some pros and cons of K nearest neighbors? I think probably its biggest pro is that it's easy to interpret. It's meaningful. Like, you can say, if we pick something like the bike rentals data set, hey, the reason why we think that this is going to have, 200 rentals today is because we looked at the 5 closest data points and they have a mean of 100 rentals. Okay, that's a nice sort of clear interpretation. You don't want to give, if you're reporting back on data, you don't want to like report back that you have a black box and you have no idea what happened, but it's good. Okay, you want to be able to interpret your models. I think it's kind of a pro that, so this isn't about training a bunch of weights, it's about really finding distances. Distances here meaning, right, like how do you find the 3 nearest neighbors? Remember those circles, you find the distance from the point. And the Euclidean distance via the Pythagorean theorem works cleanly in higher dimensions. Con, curse of dimensionality. So K nearest neighbors, I think, works better in small when there's a smaller number of columns. As you increase your dimensions, sort of the distances, they become a little bit warped because they spread out. I mean, just imagine this, like if you have a straight line and you pick how many points are within a unit of the straight line, we randomly distribute, say, 8 points between 0 and 2. Well, 4 of them are within a unit. But if you extend that to 3 dimensions, okay, and you take, say, 8 random points in 3 dimensions, and you give it a cube, how many points are within 1 unit of the cube? It's more like 1 because, a cube has a measure of, with 1 by 1 by 1, a volume of 1, but the whole thing is a volume of 8. And so as you move up in dimensions, things kind of spread out in weird ways, and the model can be not as effective. And it often is KNN is rarely like the best model. It often does not outperform trees, which we've seen. So, tree ensembles are often really strong by comparison. Okay, but it's fun, it's cool, and let's have some fun using it.